O- Okay, students, I am very much happy to take this class. This is about analytical geometry. You know what is that? Am I correct? We know that the analytical geometry is a geometry which analyzes the connection between the variable between the sides and angles. That's called what? A geometry, we say. Okay, so a geometry is nothing but the analysis of geometry is a geometrical analysis of the connection uh, between the sides and angles. Is called analytical geometry. So in your syllabus, the first topic is about polar coordinate system. Polar coordinate system. Okay, so polar coordinate system. What is that? So any point can be represented by r comma theta, where r is the distance between the origin to some point, and theta is the angle between the horizontal line and the inclined line. Horizontal line is this OA and the inclined line is OP. That OP distances are this angle, that is POA is equal to theta. So we can represent this particular point P by r comma theta. And this representation of a point in this plane based on the angle and the distance of the origin from the point is called polar coordinate system. Okay, so one example I have given here. Suppose the origin is here, the point is 5 centimeter away from the origin, and the angle between the horizontal line and this particular point is 47 degree. Then this particular point can be represented as 5 comma 47 degree. So this point can be represented like that. Okay, and this particular point is called polar coordinate. The system of representing this way is called polar coordinate system. Okay, I can give another example also for this. Now let us take another example I would like to give. Suppose this is for the origin, and this is the other point, you suppose Q, and this is some B. Suppose this angle is some 35 degree, you suppose, and suppose this distance from O to Q is some 7 centimeter, you suppose. Now how can we represent this particular point? Okay, this particular point can be represented by Q is equal to, first the distance we have to write 7 distance, comma, the angle between the two angles is 35 degree, so 35 degree. So the point Q is equal to 7 comma 35 degree. Okay, so representing the point on the basis of this distance and this angle is called polar coordinate system. Polar coordinate system. Okay, and let me wait here. Right, let me, what is the relation between, this is polar coordinate system, am I correct? Now what is the relationship between polar coordinate system and Cartesian coordinate system? Relationship between polar coordinate system and Cartesian coordinate system, what is that? So this is a relationship. Okay, now I will explain you what is what. Now the relation between polar and Cartesian coordinate system, that's what we are going to see now. Okay, right, now suppose I cancel this, what will come? Okay, very interesting. Oh, it is class somewhere, where it has gone. Can I open this? No, it is not coming. Now I will come back, and I am losing somewhere. Can I open this? I lost somewhere. Okay, wait. Now when I take this, what is the date today? 7. It is not here. Pages. No, here pages 1 2 coming. So what I have done here is, of course, yeah, here we have got it. So the relationship between polar coordinates and Cartesian coordinate system. Okay, so what will take place there, and now look at see the time, whether because 5 minutes only it will go on, afterwards it will not. So I have to see 6 minutes only it is. I will keep like this. Now suppose this coordinate system writing as x comma y. We know already, suppose this is x-axis, this is y-axis, this point is x comma y. That is, this point is x unit away on the x-axis and y unit away on the y-axis. So this can be written as x comma y. Now think of this particular point, the coordinate coordinate system. The polar coordinate system, you will have r comma theta. Am I correct? R comma theta. So from this triangle POA, will that hypotenuse side by adjacent side by hypotenuse side equals cos theta. Okay, similarly from this what we get, x is equal to r cos theta. Similarly opposite side by hypotenuse, y by r is equal to sin theta. From this y is equal to r sin theta. So equation 1 is x equals r cos theta, and from 2 y is equal to r sin theta. Okay, now what is the derived formula from these two? Okay, let us have that now. The derived formula is, you are squaring the first equation and adding with the second equation. Squaring first equation plus squaring second equation gives you r squared is equal to x square plus y square, because sin square plus cos square is equal to 1. You will get this. From this r equals square root of x square plus y square, and if you divide the equation number 2 by 1, that is y by x is equal to r sin theta divided by r cos theta equals tan theta. Okay, from this theta is equal to tan inverse y by x. So what we understand from this particular idea is that we can wait, and we will be enlarging that. Okay, we will enlarge and bring back what we have studied so far. So in the first case we studied analytical geometry, the polar coordinate system P of r comma theta, where r is the distance from the origin to the point, and the angle is the angle between the inclined plane and the horizontal plane. This representation of system is called polar coordinate system. And then there is a relation between polar and Cartesian product, that is x is equal to r cos theta, y is equal to r sin theta. And then we can derive the equation like this: r can be found out, theta can be found out if x and y are given. Okay, so thus we come to the end. In the next class we will be taking another topic and discussed. Okay, so thank you very much for listening seriously for the past 10 minutes. Okay, so thank you.